Hey everyone, in this session we will look at cross-site request forgery. We'll touch base on the introduction and the conceptualization to understand how this attack can happen in reality and how best this attack can be prevented. To explain this, I came up with a visual with a simple use case, and the use case is there is an application called customer onboarding application, which is just a sample application I took for explaining this. And this is a once the application is open, this is a portal where risk ranking cases will be displayed with a column probably saying risk ranking is high or low to onboard that customer onto the application. That's it. That's a simple example we have taken for this, right? And there are a few people who are also involved in this attack. Obviously, if it is a security attack, there will be an attacker, which is understood. And there is also a genuine user, which is the end user who is trying to access the application via some kind of authentication. So we all are aware of authentication. So whenever user tries to log into the application for the first time with the authentication which is in place, assume that it is a single sign-on, which means user is logging in for the first time. For the rest of the attempts, user need not to log in again and again, right? That is the whole essence of single sign-on, which is a good user experience. That's well and good. So as part of this point one, user is logging into the application and establishing the session. From then onwards, whenever user is trying to hit the same URL or getting redirected to the same application, user will not be challenged with any login screen, which we are all aware of. So that's why we are calling that user is logging into the system for the first time, let's say, where SSO token is already established and it's already active. From then onwards, all the hits, HTTP requests that are going into the web browser obviously will have the valid cookie with the SSO token, which will allow the user to get redirected to the application and see the risk ranking cases, which is quite valid use case, right? So we have followed the point one, where we understood user is successfully getting redirected to the application because of the valid SSO token, which is there in his system. That means in a user system, any HTTP hit is coming to this application that gets successfully passed through, and then user will be able to look at that particular information. And also importantly, that session allows this user's access to access the protected resources of this particular application. Okay, that's about point one. Now, attackers are also aware of this particular scenario where obviously attackers are, you can say, the pros who knows in and out of how the sessions will be established and how the tokens will be established. And yes, there is also this thin line where, okay, user once logged in. Of course, attacker cannot directly log into this application because attacker is not having access to this particular application. But what if attacker mimics some hyperlink which will be sent to the user's mailbox or through some other means? It will be sent to the user, and user will be tempted or tricked to click on that particular hyperlink. Hyperlink is more like a server URL, probably with this URL appended with, let's say, to run an activity or something else, which will ultimately go and do some malicious job. Like, let's take one step back. So, attacker, we understand attacker will obviously be a pro in the way how this application works, or a typical Pega application or any web application works. So there might be a great effort that attacker is putting in to understand. Let's take an attempt. Maybe attacker is trying hard for a couple of months to prepare a hyperlink, a URL, to be sent to the user. So how best the URL can be prepared, maybe if attacker spends, let's say, a week or a month or a couple of months, ultimately attacker figured out a way, maybe to this URL, if he passes some query string, system is able to take in and run the job, and probably it's updating the risk ranking for some of the customers from high to low. Don't ask me the question what attacker's benefit is by changing the risk ranking in this example. In reality, it can be anything. Probably attackers do not have any objective. They just want to ruin the application's use cases, or maybe they want to defame some of the organizations, or they might have their own intents of why they're doing the attack. But parking that aside, attacker has already put in a lot of effort to identify how best the URL can be constructed and then sent via an email to the user's mailbox. So genuine user will look at the mailbox. Obviously, end users will not be too much trained or not too technically sound. They will be tricked to click on that particular hyperlink. Probably hyperlink might say, hey, provide feedback. But in the background, the provide feedback button will have a logic which will go and execute a logic to update all the risk ranking cases logic, right? To update it from risk ranking high to risk ranking low. That's it. But user will never know that. All user has seen is a hyperlink which says provide feedback. User has clicked on it, and then it took them to a screen saying that successfully completed. The operation has successfully completed. Behind the scenes, user don't know what has happened. Then user might think, oh, okay, I got some email with some functionality of providing feedback. Looks like it didn't work. It's not working as expected. That's it. And user might miss that thread. But in the background, the most important information is it has already picked all the risk ranking cases in the system which has a low, high risk ranking, and it has already converted all the high risk ranking cases to low, which is run via a utility. All that happen with the help of this URL by passing few parameters to this application. You might say, hey, how come the clicking this hyperlink, it is able to run the utility and do the job? Yeah, but here the access, of course, attacker is not having access to this, agree. But attacker has prepared the URL to run the logic in such a way that user will be clicking the URL, which means with the user's access or the user's token, the hyperlink is clicked and the utility is run, and ultimately all the risk ranking cases with high are updated to low. So utility is run, right? So this is an example of CSRF attack. Let me take a pause there. So what has happened here? Ultimately, attacker wanted to do something. So attacker is able to do whatever he or she wanted to achieve. And user is not having a clue on what has happened because it's some email which has landed on the inbox and user has clicked on it, which is saying feedback, but then the feedback link was not taking the user to anywhere. It just said operation completed successfully. User didn't get any doubt or anything, just user closed that and he left for the day. This is how a typical scenario may look like, right? All of this has happened because of this hyperlink running a logic utility behind it, which has done the job. So now we understood how a cross-site request forgery can happen. Probably, if you're a developer or a tester or someone who is trying to understand this, you might think, hey, I'm utilizing Pega as a product. How can I do something so that this kind of security vulnerability can be avoided? Good news is it's way too simple. As a developer, as a Pega developer, you need not to do anything literally. I mean, you need not to design or code something to avoid this attack. Pega as a product already has taken care of this CSRF vulnerability. And the way how you need to enable the CSRF um, uh, mitigation is via some configuration settings. So there are a few references which I'll be providing. If you go through them, there are a few settings in Pega. If you enable that, probably the question might, okay, there are a few configurations which are taken care from Pega. If we enable that, then what can happen? So on the point 4, where the request, the hyperlink is triggering a HTTP request to the server when it is trying to get validated, Server will understand this is a forged request. Now the question is, yeah, how system or server is understanding that request is forged, right? How that smartness has come into the picture. That is about implementing CSRF mitigation. So Pega as a product has already taken care of that mitigation. All we have to do is once that CSRF mitigation is enabled from the Pega development side or from the platform side, then Pega will check for one more token, not just the SSO token. Pega will also look for the CSRF token for each and every request. Since this is the forged request which is coming out here in the point number 4, right? Because that URL is prepared by attacker and the attacker will not be having that CSRF token. So in the same process, in the same life cycle, whatever I just explained before, whenever genuine user is trying to click on a hyperlink, that hyperlink will miss a token, which is a CSRF token, which should have been present. Since that token is missing, it will get rejected and request will be invalidated. Probably you might see a message on the screen, 403 forbidden, something like that. So that means if we do this way, the CSRF mitigation is in place, and even with users access, attacker is not successful in ultimately running the utility on the server, which is a great thing, isn't it? So that is how a CSRF can be mitigated. If you're curious to know how that can be mitigated, right? Here is a quick reference for you. This is a place where all the security checklist core tasks are listed from Pega. And if you would like to understand how to enable the cross-site request forgery mitigation settings, please refer to this. I'll also provide this as part of the description for this session. And you will see a simple steps on how to navigate to and then how to enable a particular flags or checkboxes. And of course, in depth, there is much more, but the main idea, coming back to the actual thing, what we're trying to discuss as part of this session, we are able to conceptualize how a user can be tricked to click on something to achieve attacker's intent. That's the first part. And once we understood this, we also saw with help of the enablement of some of the settings from Pega, how the CSRF attack can be mitigated in the future, right? So that's it for now. Hope you all understood. If you have any questions, please feel free to comment. Thank you. Happy learning.